Good afternoon, everyone. Welcome to our Master of Science Industrial and System Engineering briefings. So my name is Chen Nan. I'm currently the Deputy Head of Graduate Programs in our Department of Industrial System Engineering and Management at NUS. Today, I'm very glad to have all of you coming. And together with me, we have our Program Manager, Junwei, who is overseeing all the administrations of this program. I'm also glad to invite one of our distinguished alumni who have graduated 10 years ago from our program. And I would like to invite him to share his personal experience with the program and how the ISC program is helpful for his subsequent career development. Okay. So for these sessions, we have 40 minutes altogether. I'm going to introduce our program briefly in 20 minutes. Then we are going to have a dialogue session with our alumni, Mr. Chen Huaxun. And as a last, we are going to reserve a few moments for question and answers, okay? At the same time, if you have any questions you would like to ask, you can send in the chat room, okay? And also you can take note of our contact information at the last in case you want to ask questions in the future. Okay, so without further ado, let's start. So since many of our potential candidates in this program are from a different major other than the industrial system engineering, I would like to spend a few moments to introduce what is industrial system engineering. So from the Wikipedia, we have a definition for industrial engineering, which is a profession for optimizing the complex processes, systems, and organizations. Okay, and these systems are generally involved with people, money, knowledge, information, and equipment. So as you can see from the definition, we are not particularly concerning a single type of equipment or process. We are looking at the system. So if you feel that this complex definition is not very easy to remember, I like this one-word sentence. Engineers make things, while industrial engineers make things better. So this one sentence summarizes what we do in the industrial engineers. So one thing that I will clarify is about our names. So you may heard about different names about our professions. So you in some of the departments, we call it industrial engineering. Sometimes we call it system engineering, or operation engineering, operations research, management science, operations management, engineering management, and logistics management, and so on. And also some departments are using combinations of some of the names, okay? So for example, we have industrial and system engineering as part of our department name. So even though they have different names, especially if you are talking about different language, even only English, we have so many different names, but they are referring to partially the same thing in the bigger scope of industrial engineering. So to give you some ideas of what industrial engineering is about, let me share with you a bit of the history of the industrial system engineering. Okay, so in the early stage of the industrial system engineering, actually one of the pioneers, James Ford, right, who is a pioneer of the current scientific management. So during that era, before the 1980s, the central theme of the industrial engineering is to save cost, increase efficiencies. Okay, so one picture here I use is the Ford assembly lines developed in the 1910s. So at that time, by specializing the jobs and the people become more efficient, less error prone, so we can increase the productivity and reduce the costs to a significant amount. Okay, so many of the techniques, management principles developed in IE was motivated by the problems in that area. Okay, so after the mass production becomes possible and people are not short of food, not short of things, then people have a higher requirement. We look at the qualities instead of having something alone. So the subsequent development of industrial engineering was quality-centric or quality-focused. So this was especially in the year of 1980s and 1995, driven by the automobile industries, okay? So as you may have heard about, the Toyota auto manufacturers was the one that has a very famous brand for its quality reliabilities. Okay, so here I have one information I get. So in 1981, for the 10 most reliable cars in that particular year, 8 out of the 10 are made by the Toyota. Okay, as you can see, the Toyota was very famous due to the high quality, high reliabilities of the car they make at that time. So the Japanese car manufacturers made a significant progress and also methodology contributions to the IE professions due to the quality driven requirements. Okay, so after the quality becomes an issue that everybody can enjoy, then the next step is to customize. So people want to have more personalized, more customized equipment, the cars, or other things. So the customization becomes a focus for the IE and for the industries, regardless manufacturing or service. So we want something that is highly customizable and something can reflect our personal interest. Okay, so here again using the car examples. So if you log into many of the websites, you have a lot of flexibilities in choosing the car in terms of color, the materials. So here I just have a screenshot of one website. You can choose anything in these categories. Okay, so you can say it's a highly customizable products at the current stage. So compare with the early stage when we have a cost-centric. So one famous statement you may heard about from Henry Ford is that the black car is the only thing that they want to produce because that's the standardized, easy to produce, low cost, effective things. So in contrast, we want to have something more customizable. So this again, as we go to the next era of Industry 4.0, or sometimes we call it the Internet of Things, or manufacturing 2035. So for different names, they're referring a new concept of manufacturing. So maybe a few years later, we have the chances to print our own cars using the 3D manufacturing or using some other digital manufacturing techniques. Okay, so as you can see from this brief histories, the industrial engineering play a key roles in different stage of the industrializations. And I believe our industrial system engineering skills will also play a significant roles in the next Industrial 4.0 that is going to come. To give you some ideas or concrete examples of what we do at IC. So here I use a few examples. The first example is in the manufacturing, especially for this highly automated manufacturing, like the TSMC, Micron, the semiconductor manufacturing. So many of the process are highly automated. We don't require a lot of high intensive labors, but at the same time, there is a high challenge on the schedulings, the optimizations, inventory management, supply chain management of this different process. Okay, so the semiconductor manufacturing is generally having a long lead time from 3 months to 6 months, and it's a high investment requirement. And also the quality of the chips have a significant impact to the society, to the customers. So as a result, a lot of our graduates, they go to this semiconductor manufacturing for process optimization, for yield optimization, for quality improvement, for reliability. So these are the typical applications of ICE in manufacturing. Of course, you will see not only in semiconductors, but in other manufacturing as well. Okay, for example, oil and gas, these are also the places where our graduates can find their jobs. So another large sector that we have significant footprint on is the logistics. Okay, so actually one of our key elements in the module is the logistics, including the supply chain, the transportation, and also a different part of logistics, the intermodal logistics. For example, we look at how the sea transport, airport transport, and also land transport can interact with each other so that the customers can enjoy the fast deliveries, especially the last mile delivery problems. So aside from these two large sectors of economies, manufacturing and logistics, so the ICE plays a very important role in many other large organizations as well. So in fact, every year we do have a lot of demand from the companies, from the banks, from hospitals. They engage our students to work on the project to reduce the process weight, increase the productivity, reduce errors, and re-engineering their process. Okay, so they have found significant values from the ISE knowledge that can improve their internal efficiencies of different kinds. So even in the new economies, for example, this sharing economies, the ISE skills and knowledge play a significant role. So here I give you one example of this car sharing or taxi sharing problems. So the Grab is one of the biggest companies in the field in the Southeast Asia. So they provide the service for ride sharings, either by taxi or by some other private car drivers. So one important problems that we need to solve is to matching the supply and the demand. Okay, so everybody wants to have a low cost ride. Of course, this is the ideal case. But if there's no profit for the drivers, so nobody is going to provide that demand, to provide a supply to meet the demand. Okay, so one important task that this type of platform companies need to solve is to provide the right incentive, price incentive, so that they can better meet the supply and demand together. Okay, so this sounds to be a very simple problem, but in fact, it involves a lot of data analytics, optimization, and decision making. Okay, so from the very early to analyze what is the demand patterns at a different time in different weather. So this will be a data analytic task. Okay, so the demand is going to change at different time in different location at different weather conditions. So we need to have a data models that can accurately predict the demand in the next few moments. Okay, then from economic point of view, the price is a driver for the demand and the supplies. So we also need to have the curve that can indicate how the demand and the supply is going to change as the price changes. So again, in economics, this is something we assume there is a curve given there, but in practice, we don't have such knowledge. So this has to be learned from the data as well. So based on the historical samples, based on the historical behaviors, we can learn such price patterns. Okay, so this will be something, again, we can learn from data. And after that, we are going to do the optimization, including the matchings, including the routines, including the redeployment. So all of these are the optimization and decision makings. So as you can see, these are the critical elements in the industrial system engineering skill set. So later on, when we talk about the modules, you will see a lot of applications of our modules in this type of problems. Okay, so again, this is an example for the part logistics. So this is one design that our department faculty, professors, together with the industry partners, they have designed this next generation part who have won them $1 million prize from the Singapore government. Okay, so the part design, logistics, operations is also something that is very critical and requires a lot of skill set from the IC. Okay, so for the sake of time, I will cut short of these examples. You will see many of these examples on our website to demonstrate the research and the projects of our faculty members. So this is a project working with power plant companies on their integrated system reliabilities, how to prevent or reduce the outages of the power generations. Okay, so as you can see from these examples, our industrial system engineering has a very broad scope. And in fact, if you look at from our graduation employment, we have almost the same percentage of employment as the Singapore GDP compositions. Okay, so we have graduate students working in manufacturing, in service, in finance, in logistics, government, and the offshore chemistries. So this is pretty much the same as our GDP compositions. So here are a few samples of the companies that our graduates have worked in the past. Okay, so some of them work in the banks, like UOB, Bank of America. Some of them work in the oil and gas sectors, ExxonMobil, Cameron, and as we mentioned, semiconductors, the Micron, Infineon, and Grab, Shopee. These are the new economies. Okay, so many of my PhD students, they also work in these different companies as well. Okay, so regarding the job scope that we do in these companies, right? So here we take a few screenshots of the graduates who have worked in different sectors in different companies, and also their job scope. So I summarize a few of things together here in this page so that it's easier for you to follow. Okay, so as you can see, some of the jobs are non-specific to any majors, but our industrial system engineering training can be very helpful. For example, the business analytics, business integration, and supply chain analysis, procurement planning. These are the key sort of our hardcore techniques, logistics. And we also have a lot of companies in consultancies, management trainings. And in the recent years, as the data becomes hot, a lot of people joining the different type of companies for data analytics and data scientists. Okay, last but not least, we have also students working as a product manager, project manager, technical sales, etc., solution architect, this type of problems. So all these things, as you can see, many of them, they do require a system perspective of the entire process, not a particular task, but from overview from the system levels, how can we do things better? Okay, so these are the exact trainings that we can provide through our modules in this program. Okay, so our department, we total have 4 different master programs. Later on, you are going to see the previews from us, other programs. Here, I mainly focus on the first one, industrial system engineering. So this is one of our earliest programs in Singapore, in NUS. So we started in 1981. Currently, we have about 120 students every year. To graduate from this program, you will need to finish at least 10 modules with the average cap to be 3.0. Okay, so out of 5.0. So to cater for the personal interest and the career development for each of individuals, we do provide 4 different specializations, including data analytics, engineering and service management, operation research, system engineering. So these are the 4 specializations that are specifically designed for different persons. So, okay. So of course, if you want to have a broad reach to different areas, you can choose to have no specialization at all. You can take modules from all these all specializations to your wish. Okay, so our industrial system engineering master program is the only master program in Singapore in these majors. Okay, so in fact, our ISEM department is the only IE department in Singapore. So we have a long and established track record, and many alumni are actually taking the senior leadership positions in Singapore now, including LTA, MPA, the Fair Price, Smart. Okay, many of our alumni are working in these key positions. Okay, so you also have a chance to work with the faculty members on research projects. If you want to go further studies later on, we do provide the flexibilities for you to work on the research projects. And if you want to have a time to work as interns, that can also be catered to. We have modules that can cater to your internship demand. Okay, so during your study here, you can plan your modules well so that you have sufficient time for interns, for research, depending on what's your next plan. Okay, So many of these informations can be found online, so I will not go into details. So these are the module requirements for our 4 specializations. Okay, so there will be a specific requirement how to get specializations in each of the area, and you can find detailed information on our website. Okay, to briefly go through the criteria for the applications, we do require a minimum bachelor's degree with honors in engineering, science, or related disciplines. So many of our students are having a degree not from industrial system engineering. Okay, so we do welcome students from other engineering, science, and the related background to apply to us. Okay, we even have pharmaceutical students apply to us before. Okay, so as to make your case more competitive, we do want to have a strong performance in the prior studies, or you have a relevant industrial experience that can contribute to the programs and contribute to the classmates. And the last but not least, for the non-English first degree students, we do need the English test scores, either TOEFL or IELTS. We follow the minimum standard from the NUS guidelines. Okay, so which means TOEFL 85 and IELTS is 6.0. So we do have an intake every year. So we have the intake in semester 1 every year. Annual intake is around 120. For full-time students, the duration of a candidate period is 1 to 2 years. And for part-time students, it's 2 to 4 years. Okay, so the tuition fee this year is 51,360, including GST. Okay, but this subject to change from time to time, either due to the GST change or due to the tuition fee change. Okay, so you please check on our website to find the latest information. So this is only indicative numbers for now. Okay, so for the sake of time, I will stop here. So here I provide 3 links that you can follow. We have a LinkedIn page, Facebook page, and also WeChat page for our department. You can scan and follow that to get the most up-to-date information and activities, and also the application information from the department and from our program. Okay, so if you have any questions regarding this program, please take a note on these 2 contact informations. So I'm Chen Nan. I'm a program director of this program, and also we have a Junwei as the admin managers. So these are the emails. So if you have any questions, you can send us email later on. Okay, so that will be all for my presentations. Okay, so as I mentioned, later on we are going to have a Q&A sessions. In the meantime, if you have any questions, you can send your questions in the chat rooms, and we are going to we are trying to answer that. Okay, so for the next few moments, let me invite our alumni Hua Xun to share with us his experience. Hi.
Good to catch up.
Good catch up. Okay, so
with you again. Hello, can you hear? You can hear me, right? Okay.
Yes. Okay, so maybe let me do a quick introductions of Hua Xun. Okay, the Mr. Chen Hua Xun is an analytic leader with diverse research and industry experience in multiple domains, including banking, quantitative trading, payment, gaming, hospitality, and the supply chains. Okay, as you can see, he has a very diverse background, which illustrates how the IC students can work and can perform in different fashions. Okay, so currently Hua Xun is the head of data analytics at the group wholesale bankings at the UOB Bank, and he is also the adjunct faculty in the business school of NUS. Okay, without further ado, maybe we can start the dialogues. Okay, so Hua Xun, do you mind introducing yourself? What's your education background, and what are the different job scopes you have held on in the past few years?
Sure. Thank you, Professor Chen. I think it's a great opportunity and honor to meet you and the fellow prospective students, right? I'm pretty sure some of you are going to choose these programs. My name is Hua Xun, as just now I think Prof. Chen introduced. I think I graduated from these programs about 10, 11 years ago, many years ago.
11 years ago, yeah.
Besides that, I do have about 11 years from a different faculty called Electrical Computer Engineering, right? As just mentioned by Professor Chen, I think after my graduation, I think from the IC, master degrees, I actually tried quite a few different industries. Gaming is one of them. For your information, for some of you are less familiar with the hospitality industry. The gaming is not the same game you play on the phone. The gaming I'm talking about here refer to casino and hotels. Yeah, where people go there to have some fun, right? Responsible gaming. Yeah. Afterwards, I think I moved to a payment company called Visa. I'm pretty sure some of you know this, right? Your credit cards, issue either by Visa or MasterCard. But then after a short while, I think I decided to say, now let's try something which is a little bit more challenging. Just fortunately enough, back then I managed to get some investors. I start up a hedge fund, right? So using the algorithm to make trade and get some profit from there. And not very long ago, I'm talking about 5 years ago, yeah, I managed actually to join a bank, which is UOB as of now, to help them to set up a new analytics unit using data to find the original business origination opportunity, using data to identify the potential risks in the business, not just from the credit perspective, but also from the operational risk perspective. Some of the stuff you commonly heard in the news or the TV, like anti-money laundering is one of the stuff we're looking at. We're also trying to use the data actually to identify who are the potential customers we can cross-sell, upsell as well, right? These are all the stuff I think we do. How does that tie back to, the education I did in NUS? These are some of the stuff I shall share with you along the way. It sounds to be not very relevant, but I can share with you with very vivid example. I can even quote the chapters I think I studied from the modules and the professor names after 11 years. Yeah. Sorry, I think return the time back to you, Prof. Chen. Let's carry on the dialogue. Yeah.
Okay, thank you. It's a very remarkable career path. Many of your positions are very close related to our daily job, daily lives, like payments, bankings, and even the gamings. Okay, so you mentioned earlier you have a bachelor degree in electrical engineering, right? So why do you choose IC as for your master degree?
Okay. I think after I graduated from electrical engineering, right, I really want to find a job that allow me to design the PCB, right? Have the coolest devices, I think, from the world. But unfortunately, back then, right, in the year of middle of 2000s, I think it's not a great times, I think, for you to looking for job opportunities, in semiconductor industry. Yeah. So I say, never mind. Let me focus more on the computer side. I carry the computer engineering, right? So I began my job, I think, in the programming side, be a computer software engineers. But after a while, I say that, okay, I can't just do programming alone. I can't just focus on building the UI. I need something which can help me to digest the information and process it and come up with something which is useful. As of now, I call them insights. Back then, I do not know. I call maybe something like an outcome, right? And also, I think I spent a couple of years in the school doing some research as a research engineer. And I noticed that I got to do advanced degrees. Whatever I learned from bachelor degrees set me very well for entry-level job, but I need to upgrade myself with advanced knowledge. And the top one pick coming to my mind is the master from ISC. Back then we still called ISC, right? Now we still, of course, industry and system engineering. Yeah. And I noticed some of the modules inside I think are extremely useful. And by now, trust me, for some of you have go through some of the tests before, some of the quiz allow you to bring something like a help sheet, right? I still keep the help sheet for each single one of them, laminate them properly, do a digital copy. And why do I do this? Because on and off, I need to use this knowledge. I can quote one good examples, right? The stats module I learned early on that allow me to help to compute a proper sample for me to do investigation in the ML space, any money laundering. You got tons of customers in the bank space. You can't simply check each single one of them. You have to do samples. But what is the right sample size you need to choose? All this knowledge you learn from the stats module will come in. Similarly, for the design experiments, I think the module that I think back then Professor Go Tui are the one teach this. I do not know whether he's still around or not. Yeah, he teaches us how to think systematically, right? System engineering sounds very, sounds like something always linked to engineering. Trust me, it is not. What matters is the knowledge, is the way of thinking, help you a lot. Whether you apply to engineering, in the semiconductors, in the maritime offshore, or even in the banking sectors, that all matters. I have numerous more examples in the forecast taught by Professor An Bonghua, in the quality engineering taught by Professor Chen Nan here, right? Back then he shared with me how to do parametric, analysis and no parametric analysis. I still keep all those notes. Yeah. So I don't want to take too much time. Again, I think return the time to you, Prof. Chen. Yeah. Is there any other stuff I think I can share a bit more?
Yeah. Thank you very much for the vivid memories for your years. I still remember I think for the other students the information. So Hua Xin graduates ranking first in the program. So he just shared with us how to excel in this program, and that can help you in the future. Yeah. So one thing that I believe many people will be interested in is that you have a job scope in different industries with a very different kind of background. So how do you find that the IC knowledge and skills can be helpful in these different type of jobs you have?
This is a very excellent question, frankly speaking. In the first few years, I also asked myself, what made me qualifying for the job in other areas, right? I probably worked in a research institution in the past. I jumped into a consulting firm. I jumped into a gaming company, and afterwards I moved into payments. What are the key factors that why the interviewers, the hiring manager decide to hire me? Initially, I do not know. After a while, when I become the hiring manager, I noticed a couple of things. First of all, for each of the jobs which I do or I did in the past, that you need a few key components. Number one, the problem-solving skills. That one, you just can't run away. You need a very systematic way to think about the problems, and then you can solve the problems. Industry system engineering help you prepare that nicely, despite the fact in academic environments, right? It's a master degree. Yeah. It helps you prepare nicely. The design of experiments, the quality engineering, and some of the facility layout taught by Professor M. Kim Min, it helps you to lay out the problems step by step, and it helps you to form that thought. And that thought will hold a lot of value across different industries. That's point number one. Point number two, some of the fundamental knowledge in stats, in data analytics, and in OR. These are the things essentially set you apart from the rest of the job applicants. It sounds so straightforward. I mean, nowadays the knowledge is everywhere, but don't ever forget, for you to pick up the knowledge by yourself alone from Wikipedia, from Google, or from other space, you need to spend tons of amount of time, and more often than not, you're probably not necessarily on the right material, on the right track. You need somebody to guide you. ISE have the world-class faculty, at least during the year of 2010, right? This is the data point I collected back then. Now, I still believe that legacy will carry on or continue. You have the best faculty member there. You have the best resources there. But that doesn't mean that, once you'll be enrolled, you will be guaranteed for success. Definitely not the way. It's really up to you. How much do you want to learn? How desirable do you want to have in your lifetime? You helping people to solve the problems, and you gain the value in returns. The desire of yourself play a large part, despite all the support and the resources the school, the faculty member can offer to you. That is something you have to ask yourself. Do you want to spend all your efforts, and are you sincerely want to spend the time to enroll this program or not? Ask yourself before you enroll to these programs. Otherwise, after going through 1.5 year or 2 year the program, you feel, no, Professor Chen Nan or Hua Xin is actually not telling the truth. Trust me, from bottom of my heart, I share with you, this is the truth. I benefit or not from that. But in the same time, you need a commitment from you also. You think carefully for all the prospective students. Yeah. Return time to you, Prof. Chen. Yeah.
Yeah. Thank you very much for sharing the first-hand experience as a job applicant and also as a hiring managers. What are the companies looking at? Okay. So maybe you can give us, especially the potential future students, some advice if they want to do well in this program. What are some knowledge, skills, and also maybe some other things that they need to prepare or they need to take note?
Okay. First of all, the fundamental module like OR, make sure that you know this. Stats, you got, it's a fundamental module, compulsory module, you can't run away. Make sure that you have a proper establishment in these areas, because no matter which industry you're going to be in, you need this. Somebody may argue that I don't need this, I'm a sales manager. Yes, to be an average sales manager, you may not need, but to be the top ranked sales managers, these potentially sometimes may add in value to use. Yeah. And also, I know that some of you say, you know, in the future, I'm going to work in the manufacturing industries, etc. Right? But the programming skill set, I think, might be something potentially will be useful. This is one of the core components that, really, if you can, I recommend along the way you pick up. Right? For some of the primary school students or even secondary students, I mean, in Singapore context, right? Programming is become part of the curriculums. Right? If you're never exposed in programming before, progressively, gradually pick that up. And the last one is the logistic part. Some of you may think, okay, you know, you guys, you know, I'll be working mostly, I think, in, you know, service and financial industry, less, I think, in the traditional manufacturing industry. You know, why I mentioned logistics is something which is very important. Yeah. Look at the big, I think, mega trend in the last couple of years. In the past, the whole world is very much connected as one village, right? Whatever stuff that people consume in US or Europe, they got it manufactured in China's, Southeast Asia's, including Vietnam's, right? They call offshoring. But given the recent incidents that the potential trade tension between China and US and the conflicts between Russia and Ukraine, some of you, if you're sharp enough, you probably observe certain portion of the supply chain has been disrupted. And look at, you know, the cross-border logistic fee that increased more than 10 times. The commodity price, the petroleums, and some of the agricultural products, simply because I think, you know, either the supply chain has been disrupted or because the country who produce this commodity, like the barleys, yeah, from Ukraine, has been disrupted. All these are the important information help you to form the view at the macro levels. And if you know the logistics supply chains during your master study, you'll be able to appreciate this much better. And the story doesn't end stop from here, right? Whether you're working in the financial industry or manufacturing industry, this macro stuff is going to cause an impact to the industry you are in, particularly to the company you are in. To have this leading signals and to understand in advance, will help you to prepare. Assuming back then, you know, afterwards, I think you become, let's say, a general manager of the company. All these are the important information to help you prepare better and have the potential crisis. That's why I say these are the important information from my perspective. But it doesn't mean that for you that this is the only thing you should take care, right? Blend that with your own personal needs and the interest, right? You may have a different interpretations. Okay, return the time to you, Prof. Chen.
Okay, thank you very much for the generous advice. They are very helpful. Due to the time limit, we are going to stop at 5:40. Okay, so we have to stop the dialogue here. But please keep monitoring ours. We are going to organize alumni events and alumni sharings in the future. So please follow our social media platforms. Okay, so any questions before we stop? Anyone from the audience?
Yeah. If any of you that you are a little bit hesitating, you're not convinced, feel free to pin me as well if you want. Yeah, happy to share some experience with you as alumni. Yeah.
Thank you very much. Yeah, so here are the informations. Please take notes. You can send us emails later on. Okay. Okay. Okay.
That's
thank you very much. Yeah. Thank you.
No problem.
Yeah,
thank you,
yeah.
Prof. Chen. Thank you for all the prospective students. Yeah. Nice to see you here. Yeah. Bye bye.
Okay. Bye bye.